All right, we are in Precalculus. Today is Monday. Today's date is the 4th of March, so 3/4. It is not the 5th. Tomorrow's the 5th. Yeah, so geometric sequences. We are doing geometric sequences. We've been in arithmetic for a long time. Today we get into the geometric land. All right, so just a bit of review. When I say an arithmetic sequence, give me an example. Arithmetic sequence.
Arithmetic.
2, comma, give me a list. 4. The next one would be
6.
then
10. I'm just kidding.
8, yeah, et cetera, et cetera. Then what is an arithmetic series?
2 plus 4 plus 6 plus 8.
4 plus 6 plus 8. I'm going to try to do my 8s that way so they're all in one piece. All right.
Yeah.
Geometric.
That's what I do.
Really?
Yeah.
Oh.
Geometric.
Geometric, so that's going to be 2, 4, 8, 16.
Yep. 2, 4, 8, 16. Ah, see, I forgot to do the 8 that way. And in order to turn that into a geometric series, Daisy,
You act.
yeah, 2 plus 4 plus 8 plus 16. Change the
8, you should say infinity to help you.
sideways infinity. There we go. All right, so our first 3 examples are pretty straightforward. Example 1 and 2 are really easy. Example 3, a little bit of review maybe, and example 4 is a brand new thing. So what is the next term in this geometric sequence? What am I doing each time? Each jump, what am I doing? I'm now multiplying or dividing. I'm not adding or subtracting, so what am I multiplying or dividing by?
By 9.
Each time I'm multiplying by 9? A good guess.
3?
Say again?
Dividing it by 3?
Close. So to get from 25, negative
Oh.
25 over thirds to 25.
Yeah, so you're timesing it by 3 because they cancel each other out.
Oh, timesing by 3.
Oh, I said dividing.
Oh.
Yes.
Timesing by 3. You're really close. Notice how it goes positive, negative, positive.
So it's times negative 3.
Times by
positive 3.
negative 3
Oh.
each time. Because a negative times a
Oh, yeah.
negative is a positive. So what is the next term then?
75, negative 75.
Negative 75. Are we all okay with the example? And that's the homework problem. Let's go to example 2. All right, this is just using a formula. So what does b of 1 mean? What does that literally translate as? The first term, exactly. So the first term is, equal sign means is, 6 over 25. And to find any term, b of n, I take the previous term, again, b of n minus 1, if you are scared of him, this guy just means previous term. Take the previous term, and then do what to the previous term? Multiply by negative 5. So I'm going to have to find the 4th term. Okay, well, the first term is 6 over 25. That was the first term. The second term will be what?
It would be 6 over negative 4, 5.
6 over negative 5. Looks good. I should try writing my 5s all in one stroke also. Let's try it. I just know that I go so fast with my 5s, it's sometimes hard to...
Negative 5. Or multiply by 5.
And then Daisy, what's the next one?
Right.
The third term is going to be...
Oh, you're asking me.
Yep, so I'm going to multiply negative 6/5 times negative 5, because that's our rule. My next term, my third term, is going to be... Careful. So if I multiply this guy by negative 5, the negative 5 and negative 5, shunk,
Oh, so it's going to be 6.
it's just going to be 6. And then finally, Rochelle, our 4th term is going to be
Negative 30.
negative 30. Because again, I'm just multiplying 6 by negative 5. I keep multiplying by negative 5 over and over and over again. So my final term is negative 30. Box it. That's our final answer. We're looking at 30. Fist of 5. How well do you think you can do this on your own for a brand new problem? 5 is, I will master this. That's easy peasy. 4 is like, I'll probably get most of it. Where are we? Fist of 5.
For what? Example 2?
For example 2, yeah.
Oh.
4.5.
Okay, so pretty high scores, 4 and a 4.5. All right, so explicit formula. So here is our explicit formula. This is something that you will need to memorize. So I'm just assuming some letter. I could have chosen A here, B, C, D. I chose C because it's our third thing that we're doing. So if I'm looking at the explicit formula for a geometric sequence, that geometric sequence is going to have some starting value. So I'm going to say start. Sometimes people call it the initial value. Sometimes it's the start value. But it's whatever the value that you're starting with. And then I'm going to multiply. So it's going to be times. And now I'm going to do the rule. And this thing is usually called the common ratio. I'm going to call it the common ratio as well, just be formal. Common ratio. If you don't like that term, use just rule. It's the rule. Like if the rule is multiply by 3, then your common ratio is going to be 3. If your rule is divide by 2, your common ratio is going to be 1/2. This has to be something that you're multiplying by. So if you want to divide, and this is really key because it's going to come up, if you want to divide, this is really going to be a fraction. Your common ratio is going to be like 1/2. That's the same thing as dividing by 2. This always means multiply because that's a multiply. It's going to be your common ratio to the power of, this whole thing, to the power of
2.
n, but not n because we are starting at the first value. If we started at the 0th value, then this is correct. But since we're usually starting at the first value, how do I have to change n? It's not n, it's n minus 1. Yep. This happens because we start at the first value, not the 0th value. Again, if we did start at the 0th value, then we just put n. Hey, look, it's a formula. It looks really similar, yeah? Okay, let's find it. Find the 4th term of the sequence. Literally plug in 4. So, let's do that. D of 4. D of 4. I'm plugging in 4 everywhere I see an n. I'm putting in 4. So that's going to be equal to negative 3/4 times negative 2. All of that to the power of 4 minus 1. So it's really to the power of 3. We can do this in our heads. What is negative 2 times negative 2 times negative 2? Or negative 2 to the 3rd power? What is that?
Oh, negative 8.
Daisy, do you agree? Negative 2 times negative 2 is?
No, wait.
Yep, it's 4.
It's 8.
And
Like-
then
like
times
a-
negative 2 again,
It's 8.
negative 8, right?
Negative 8.
So this is all negative 8. So let's turn this now into, I'll use a different color here. This is now negative 3/4 times negative 8. And what is negative 3/4 times negative 8? It is 6. Because 8 divided by 4 is 2. So 2 times 3 is 6. A negative times a negative is a positive. We do indeed get a positive 6. That's the answer. Pretty straightforward. Know how to do that? All right. And finally, example 4. This is going to be a brand new thing. You need to have this explicit formula memorized because we're about to use it. Have it locked in your mind. You're ready to go. It's start on the outside, the common ratio on the inside to the power of n minus 1. All right, I need to find the explicit formula for this geometric sequence. What am I going to do? Let's choose a random letter. Or a symbol. Or a Greek symbol. Or anything.
Let's
Oh God, you're going to quiz me on my Greek symbols. Okay, what are we doing?
do Ida.
Which one?
Ida?
Ida? Eda? Yeah, I don't know actually how to pronounce it. I think it's Ida.
Ida. Let's use
Capital Ida or lowercase Ida?
Capital.
All right, so it's basically capital H. That works. Ida of n is equal to, all right, what's my first thing that I'm going to put for my formula? The start. What is the start value or the first value? 256. Notice that this is the first value, not the 0th value. The 0th value isn't given to us. We would have had to gone backwards one. 256 times what? What is the common ratio? What am I multiplying by each time to get from 256 to negative 64? Or better yet, to get from 16? Yeah, so Daisy, do you see that? To get from 16 to negative 4, I have to multiply by negative 1 over 4. So my rule here is negative 1 over 4. What is this going to be to the power of?
9 minus
There it is. That's the answer. Each 4 examples is its own homework assignment. Got it? As a note, you can have a different formula, and I haven't actually looked at the Khan Academy assignment, but I have a feeling that they'll do this because they did this with arithmetic sequences also, which is that h of n can also be written as this. If I want to use the 0th value, if I want to go backwards from 256 to the 0th value, I need to undo multiply by -1/4, which is the same thing as divide by -1/4. So if I'm multiplying by -1/4, multiply by -4 this direction, 256 times 4 is 1,024, right? I think so. 1,024, let's just trust me, because 25 times 4?
20.
What?
25 times 4?
Oh, 25 times.
25 times 4?
1,000.
Or yeah, 250 times 4 is 1,000, and then 6 times 4 is 6 times 4. 6 times 4. 24. So 1,024. So I could have used the 0th value, 1,024. Write it down. I could have used the 0th value with the same common ratio, -1/4. And now instead of doing n minus 1, it's now going to be. So this, this. So this 256 here, that was h of 1. And because we had a 1 here, h of 1, we had to do n minus 1. So if I'm using the 0th value, this is now h of 0. Now it's going to be n minus
0?
Yeah, so it's just n. So there's 2 different ways to write the formula. Usually you're going to use this first one because it's easier, and then sometimes if they're going to try to trick you, sometimes they might give you the second one. Questions? All right, go ahead and write your summaries, and then you may begin on Khan Academy.